We start a bit with explaining a bit about how apt is structured. So sort of with three kinds of components that we can actually do some sandboxing of. There's like the downloading component, which runs individual processes, so one process per host to download files. There are packages that we're installing with dpackage, which then runs maintainer scripts and writes files to the file system. And of course, there's hooks. You can configure hooks in all sorts of places, like before installing a package and after installing a package. And yeah, after updates, before updates. Basically, any operation you can schedule a hook. And apt itself is, of course, used in a variety of places. So there are two systemd services shipped with apt. One downloads updates and the other installs updates. And PackageKit, for example, is a daemon that uses apt. And finally, you can use the apt programs to interact with it on the terminal. And sandboxing that all is a bit complicated, perhaps. But what we have so far is a downloading sandbox. It's not entirely perfect. So you can see the downloads work by having each process. Each host has its own process, and the entire sandbox has a directory, a partial directory where files are written to. The directory is owned by an _apt user, and the process is run as the _apt user. But the problem is the _apt user, the processes that download the files themselves verify the file integrity. So essentially the sandbox tells us, hey, all downloads are correct. Please trust us, which of course is not entirely optimal. And if you want to fix that, basically the idea, move the files out of the partial directory when they're done downloading and then verify them. But of course, I think most people know, if you move a file, you don't know if anyone else still has write access to it, because you can't revoke file descriptors. Or can't close file descriptors for other applications. So you can't actually move the files, but you have to copy the files, which is super slow. And instead, of course, if you have Btrfs or XFS, you could also, of course, use a reflink, which would be faster. And it's also not the cleanest architecture, I think. And another architecture you could use, if we redesign it from scratch, maybe we could download it to a pipe. Then we can close the pipe when we're done and can verify the data that was sent. And then we know that nobody else is writing to our file because we're the only ones that can write to the file. And in that case, we would essentially we would open the file in a trusted process, and then we would send the writing end of the pipe to the download process over a socket. But that's also sort of a problem, because if you open the file outside and then pass it into the sandbox, you have to make sure that the sandbox doesn't influence where you open files in. And I think right now it determines the file names based on where they're downloaded from, to some extent. So that kind of creates a bit of a security issue as well. So it might be nicer to actually do the slow solution instead of this one, because this adds another attack surface. It was implemented partially a couple of years ago, but never completed, I think due to lack of time. Of course, there's another new feature in the kernel. And somebody asked me on IRC.
What was that?
He's here, yeah. And the landlock feature, you can use landlock to say limit which directories you can open or which files you can open or create. You can say you're not allowed to create. Well, you are allowed to create devices, or you can say you can write to this directory and you can write to that directory. And yeah, the initial idea was to use landlock to protect the home directory from maintainer scripts, but this didn't work because if you want to actually use landlock to protect home, you would have to not give write permissions to the root directory. And at that point, when you're installing packages, of course, the packages need to be able to write to the root directory. For example, you could have a package that introduces a new directory like /EFI. Right? So that would have to write to the root directory, and then you can't use landlock. But what you can do with landlock is you can use it to improve the sandboxing I talked about earlier by giving each of these download processes that runs per host its own per host directory, and then restricting writes to that per host directory. And that significantly improves security because you don't get any cross-contamination. So if there's an evil host you're talking to over HTTP that can exploit your HTTP stack, then that exploit is only limited to the files you download from that host and not to files you download from other hosts, which improves security. And then you, of course, still need to be able to fix moving the files out and verifying them, because otherwise it's not really all that useful. If we know this host is compromised, but the host tells us it's okay, it doesn't really improve security that much without fixing the other bit. But once you have all that, you have secure downloads. You can go and tackle the next thing, which is services. So I already said we have two services. The daily service downloads metadata and updates to predefined directories. So we have a var lib apt lists directory where it downloads the metadata to, and we have a var cache app directory where it downloads packages to. And then the app daily upgrade service installs the upgrades to the system unattendedly if you have configured the system to install updates unattendedly. And the problem is, I think, we don't use any of the systemd features to isolate those services at the moment. But of course, we probably should. So I started playing around with that, using systemd run to run apt myself in a script. So I basically wrote a script in user local bin that I called apt, that then runs user bin apt with systemd run to experiment with which isolation features I can use. And if you want to install upgrades, that gets really complicated because think about bootloaders. They need to be able to open all the devices. They need to iterate over all the devices. Actually, if you have OS prober, it will mount every device and then see if there's operating systems installed on them. If you want to move boot EFI to EFI, then you also need to have write access to that. And all sorts of maintainer says he's special and needs to do this and that in his maintainer script. And the only thing that I managed to actually do was the protect home feature. Of course, I broke my ability to actually apt install files from my home directory. So I have to work around that locally. But that seems to work for the service because the service is not installing files from your home directory. So applying at least protect home there seems to be a good idea.
It will break some proprietary packages.
I think that's a feature, yes.
I won't complain.
What I'm worried about a bit is mount namespaces and how it interacts with stuff like bootloaders, because I haven't checked what actually happens there. I think like NFS and AFS or something, right? All those kinds of weird file system packages, they might interact badly with the mount namespaces. So I don't use them, though I don't see it. But probably if I upload that, stuff might break. But people can overwrite it, maybe.
Exactly. So use override.
The downloading is of course easier. So if we only download files to a couple of predefined directories, we can use all these settings that I have on the screen. There are probably more settings that make sense, but those were the ones that I was actually able to use so far. And haven't actually uploaded anything into the package yet, but would like to try that soon. Essentially, the problem with that is you have update hooks that run before the update and after the update. So you can already see I have read-write path var, because when I limited it to only the directories that apt actually writes to, a lot of hooks that were recording their own state after the update, they broke. Like there was a command not found library, there was writing to var cache command not found, and then that was broken, right? Lots of tiny places like this, but I think I don't expect a hook that runs after update to write to your user directory, for example. Nothing should be touching your home directory. And yeah, nothing should be touching boot or etc or anything else other than var, I think. And yeah, I think I'm a bit early, a bit fast going through the slides. Yeah, we can take a question now.
So you mentioned the second filter.
Yeah.
And this seems like a really attractive option, right? Because you have the download process, you put it in a second filter that was you launch it with an already open file descriptor. So you limit it to network operations and writing to this file descriptor, and then it should be good, no?
So the problem we have, so the download process downloads a lot of files and it doesn't get started for a single file because it has to keep pipelining and everything enabled. So you need to download like 100 files to different names. So you have to pass in the target file descriptor somehow.
Okay, so the file directory, I guess. The file descriptor for the file directory.
You could probably fork again inside the process when you're actually doing a single file download, and then exit from that sub-process again. It gets a bit weird, maybe.
Because the other thing that you mentioned is that a process could be holding the file open. But if you limit the process, and then you could wait for it to exit, and if you make sure that it cannot, pass the file descriptor out anywhere else, then as soon as the process exits, you would know that there are no file descriptors referring to the file, and then you could avoid the copy.
So we need to deny the dup sys call essentially to be able to prevent it from duplicating it,
or even run the stuff in a C group. If you cannot prevent forks, then run it in a C group and then make sure that the C group is empty.
It might work, yeah. One of the issues we had with seccomp filters, and that's why we disabled seccomp filters, was that essentially NSS modules, they use different system calls. So whenever we resolved host names, we ended up breaking some users, because they had different NSS modules installed.
But they only talk to resolve D. What NSS modules?
Funny comment from Debian.
In an optimal world, yeah.
You said that provide a file descriptor per file would not work, but you can give a file descriptor for each a socket operation. So you can get the request to download a file, because the app driver gets I think one internal request per file, because the parent process will look up what it should download, and you could give it in one request one file descriptor.
Yeah.
Because that's a Unix socket, or mostly.
I think it depends on how we make sure that the stuff we read from the sandbox doesn't affect the file names that we open files at. That was my concern, because when I send it the name, The download code is very old, and it grew over like 30 years. So I don't know if the output file name is actually at some point can be generated essentially by input from the sandbox. That's why I don't want to open the file as a trusted process essentially. Maybe I should rewrite all the downloading code.
You could also rewrite it not in C++.
Rewrite it in Rust.
Any other questions? So on your comment before about writing to root, there's a very simple way of solving that. We don't ship anything under root anymore, only under the user, right? That we're very close to that.
That would be nice. And I think there's one final bit that we haven't talked about. It is sandboxing the interactive user cases. And I was talking to Luca about this on IRC a bit. Essentially, if you run apt manually in the command line, you kind of also want to have the same isolation features that you get in the service. So it would make sense to have a library or, I don't know, Varlink's protocol, whatever, to be able to respawn ourselves with the systemd isolation features applied. But
yes. So, well, I can go first. So there's two ways of doing that. There's a transient unit stuff, which is just systemd run. That is a bit cumbersome to use, and it's a different thing, right?
Yeah.
That is, create a new service. Now, I have a PR open to do the executor stuff, which basically allows you to do that. Now, I don't think we will make it a public API for quite some time, if ever, but we might go in that direction at some point. And this basically means you can just create a, right now, key value, but it will become JSON, a JSON description of what you want to do, and then including the process or binary you want to execute, and you pass it to this binary, and then it does all the isolation stuff. This is coming, right, for internal use cases.
Yeah.
I don't know if we will make it a public API, but it will be there and it will work. And we might do some experiments there and see what works.
it would be really useful to have the isolation features easily accessible to non-systemd services, essentially.
I mean, I think it would be kind of nice to have a SD run call that takes a bunch of parameters and then wrap it up in a Python module and then call it instead of subprocess check call. But I wanted to make a comment in a different direction. So in the RPM world, on the other side of the globe, we are moving away from, well, we are moving towards having a DNF daemon, which, because then, for example, there's this problem that a user calls an unprivileged, like, I don't know, DNF repo query or search or whatever, and then this is not privileged, so it needs a separate cache, so it duplicates the information that's already available in the system. So what we want to do is we want to have a central daemon that manages caches and downloads, and then the user can nicely call this from an unprivileged process and maybe escalate privileges through policy kit and so on. And it also has the advantage then package kit itself becomes a much thinner wrapper. It doesn't need to do as much stuff as before. It doesn't have a separate cache. Does not use a crazy amount of system resources. But once you have that, then the model of having running stuff from the command line becomes much less important, because for the general use case you just communicate with a daemon and you don't need to sandbox.
I was thinking about writing an app daemon that uses Varlink essentially for communicating. Because sometimes I need to be able to talk to so you might not have, if you run apt in a shroot, for example, you want to be able to still run it with the daemon in a sub-process essentially and not have to start a dbus broker or something, right? So Varlink sort of makes sense to have, but maybe dbus also makes sense.
So one of the problems with the daemon is that, at least in Debian, a lot of people love their CH roots and installing packages in their CH roots. If it's a daemon, then this wouldn't work, right? You will need to model
Yeah.
the execution. So that's
If it's a varling daemon, you can run it
can
in a
run it on the
sub-process and talk
sub,
to it over a pipe.
yeah.
So I agree. I agree that the only thing, why would you need the SD run to be a library? Because it's just gonna take a bunch of arguments and exec again, no?
I mean, if it's based on the executor instead of the systemd run binary, so if it's creating it as a sub-process directly instead of creating it as a systemd unit, then you would kind of want the library to do the serialization of the JSON, essentially. I think.
Next step.
Grand vision plan.
And then the other thing, which it doesn't really help with this, but when you're doing it, when you're creating a change root directory, then you can just run apt completely in a user namespace, and all the problems really go away because it can write anywhere it isn't supposed to. But that doesn't help with this because you need to write the stuff.
I think sometimes you even need to have access to like devices. Oh. You need to make sure it doesn't lock because otherwise GNOME shell gets killed. You also need to have user namespaces on the build infrastructures of Debian, of Ubuntu, everywhere that uses apt. That is a bit hard, I guess.
Any other questions? We got 3 more minutes for questions. Any comments? Anything else to cover? Any final comment? No? Going once? Going twice? All right, let's thank Julian.